When performing centerline probing, there are a few pieces of equipment you will need, along with some settings in WinMax we will have to configure for everything to work properly. Here is the list of equipment I used for this procedure. You'll need a tool gauge, a travel indicator with a 1/10 of a thousandth of an inch resolution, a reference sphere, a master reference tool, and a part probe with an M4 Ruby stylus. Make sure that you're using at least WinMax version 9.1.163 or higher. Earlier versions don't support centerline probing. You must have the centerline probing option installed in OptiClient as well. You can use a 30-day trial. You need to be set to absolute tool length for your tool count mode under Tool Utilities and Settings. In User Preferences, go to More, Rotary Axis Parameters, and in here, set Rotary Axis ISO Standard to Yes. Then in the Auto screen, you will want to disable Linear Thermal Compensation by setting the value to No. Now we will calibrate the probe using a reference sphere and a travel indicator. Make sure you are using millimeters and not inches for this entire procedure. You can switch between metric and imperial units on the control between the on-screen calculator and the keyboard. First, you will measure your Z reference. This is important to do first before anything. Place your master reference tool in the spindle and jog down to the tool gauge until the dial makes 1 revolution and stops on 0. Make sure to zero your gauge dial beforehand. Go into Tool Setup, More, Tool Measurement Settings. In here, select the reference field and hit the Store Machine Position soft key. Then in the same field, you will subtract the height of the tool gauge and the length of the master reference tool from this value and hit Enter. Reference tool lengths are in inches. Make sure to convert their length into millimeters for this measurement. Make sure you adjust the probe radial runout according to the probe manufacturer's manual. With the probe in the spindle and set as the current tool, orient the spindle. Open the NC program Probe Tool Length, G31_6. In manual mode, jog the probe over to the tool gauge to where the ruby tip of the probe is directly above the ground flat surface of the gauge, about 6 millimeters from the tip, or the diameter of the stylus. Run the Probe Tool Length NC program. It will slowly touch the gauge 3 times, and then a box will pop up with an updated tool length. Hit Yes, and you will store the probe's tool length. Next, we're going to calibrate the probe to the reference sphere. This should be securely fastened to the C table in the upper left quadrant. With an SRT machine, you will need to mount the sphere on at least a 246 block for the Z-axis to have enough travel when measuring the tilt axis. Set rotary axis to 0. You will need to find the XY center of the sphere by sweeping it with the travel indicator. After removing the probe and magnet, insert the travel indicator and in manual mode, Tool Management, set your tool number to an unused number. Adjust your X, Y, and Z positions until the indicator reads 0 when swept around the sphere for both X and Y. Now store your machine position in part setup as part 0 for X and Y. Now we need to find the Z location for the center of the sphere. To find this, we will first adjust our indicator so that the stylus tip is at about a 15-degree angle, almost flat. Slowly jog down with the indicator on the sphere until your needle is at 0. Sweep across the top in both X and Y positions, stopping at the highest point on each axis. Each time, Z needs to be adjusted in the positive direction back to 0, and then X and Y need to be swept again to find the high point. Once you've found this point, without needing to adjust Z, store your machine position for Z as your part 0. Then subtract 12.7 inches from this value, and you will now have the Z location of the center of the sphere.
A second option at finding the center of the sphere is to use the Probe Sphere Part 0 program. Jog the ruby tip of the stylus about 6 mm from the tip of the sphere and run Probe Sphere Part 0 G31_7. The probe will locate the center of the sphere and you will store this as your Part 0.
Jog the probe over to the top of the sphere about 6 mm from the tip of the ruby stylus. Run the probe deflections NC program. This will measure your probe deflections offset values and calibrate the probe to positive and negative X and Y and negative Z directions on the sphere. Use manual centerline probing if your current centerlines are wrong or not known within 1 mm. Make sure your feed rate is set to 100% and that your rapid override value is between 1 and 9. Open manual probe G31_3_4 and change the A0, B0, C0 fields to correlate with the axis you are measuring. We're measuring the B axis in this procedure, so we'll want it to be B0. In manual mode, jog the axis you're not measuring to 0 if it's not already there. Then jog the probe over to the top of the sphere as close to the center as possible and at a distance of about the diameter of the ruby tip from the sphere. Then run manual probe G31_3_4. The control will probe the sphere for its current location and store the values in memory. This will need to be run at a minimum of 3 positions. In this procedure, we are measuring the B axis. We measured the location of the sphere while B was at 0 degrees. Now jog the B axis anywhere between 0 and negative 90 degrees. Then orient the table so that the vector of the part probe intersects the center of the sphere as shown with the ruby tip of the probe about 6 mm from the sphere. Run manual probe G31_3_4 again. The control will probe this position and store its value in memory. Jog the B axis to negative 90 degrees and orient the table again so that the vector of the part probe intersects the center of the sphere with about a 6 mm distance between the ruby tip and the sphere. Once more, run manual probe G31_3_4. Now all 3 positions have been measured and their values stored in memory. Now go into part programming and change the line that contains G31.3 to a comment and unmarked G31.4 below it. Make sure its A0, B0, C0 value is set to B0. Now run manual probe G31_3_4 a 4th time with the necessary changes, and the control will calculate all 3 positions it stored before and give you a centerline value for the B axis. Press yes to accept this new value. Use automatic probing if centerlines have been previously measured or are known within 1 mm of the actual value. This measurement will have more accurate results than manual centerline probing. First, you will set your rotary axis to their 0 positions and then jog the probe above the sphere approximately the stylus diameter away. Run the NC program from the list that matches the machine type and axis you're measuring. The control will measure the sphere at 5 different angles for the B axis and then calculate its centerline.